45 minutes if we're lucky. Okay, so this is lesson 5.5. It's a little complicated, so just pay good attention, okay? The remainder of division. Okay, when you read that, or if you read the word quotient or, whatever, it means long division. Okay, so let's do long division. Everybody in the room, tell me what goes on the outside. Is that the top or is that the bottom?
Bottom.
Good, it's the bottom. So x minus 1, and we're not missing anything. I've got an exponent of 1, I've got a constant, and I'm good. What goes on the inside, guys? Look, a 3, a 2, a 1, constant, I'm good. And yes, someone went to tell me it is the top that goes there, so that's right. So you stick that thing in, and here we go, okay? What do I multiply by x to get 3x to the third? That's 3x to the second. Now I distribute, and I get 3x to the third minus 3x to the second. Change my signs. Those cancel. I get a negative 2x to the second. Then I bring down the 3x and I do the whole thing again. So what do I multiply by x to get negative 2x a second? That's a negative 2x. Distribute, I get a negative 2x to the second plus 2x. Change my signs. Those cancel. 3x minus 2x is 1x, bring down the 10. What do I multiply by x to get x? That would be a plus 1. Distribute, x minus 1. Change my signs. Those cancel, negative 9. So read the question. What is the remainder is what they want to know. Guys, you just write that as a negative 9. No fraction, just negative 9. Okay? The other thing that I really think that they could ask you guys is what is the quotient? And we've already talked about this a couple of lessons ago. So the quotient is just the top stuff without the remainder. So the quotient is 3x to the second minus 2x plus 1. Okay, those are the two things that could happen with that problem. Okay, now look what they've done. They took the bottom, this x minus 1, set it equal to 0 and solve, and you get a 1. So now they're asking us to find f of 1, which means go into the top, and everywhere you see an x, put in a 1. Okay, so let's all write this up. So it's 3 times 1 to the third, minus 5 times 1 to the second, plus 3 times 1 minus 10. If your calculator's not on your desk, get it on your desk. We're going to do a ton of calculator stuff. Yes, honey?
So when you're plugging it in, are you not including the bottom?
And not including the what, honey?
Like the denominator?
No. No, the denominator tells you like what to put in. And that's actually a very, I understand your question. Yes. So you do not include the denominator. You set it equal to 0. You plug it in and see what you get. So look what you get. You get a negative 9. And that's always going to happen. What am I talking about? Always going to happen. Set the bottom equals 0. Plug it back in to the top. And what you get is always going to be exactly the same as your remainder. Okay. Hey, one thing really fast, Charity. If I did put in a 1 into the denominator, I'd get a 0. So then you'd know that would be a problem. Good. Okay, so let's come down here to example 10 or example 2. But I just want to say one thing really fast. Just look right here and just watch for 2 seconds, okay? So let's say we had y equals x squared minus 4. And we're trying to solve it. So we'd have x squared minus 4 equals 0. Then we'd factor. So it'd go to x plus 2, x minus 2. And you'd get a solution of x equals negative 2 and x equals positive 2. I'm sure everybody understands that. Couple of things I want to say. This is a squared, and I have 2 solutions. X plus 2 is a factor. X minus 2 is a factor. X equals negative 2 is a solution or a 0. X equals positive 2 is a solution or a 0. If I took this negative 2 and I put it back in there for x, everybody tell me what I would get. I would get a 0. So if you solve something and then you plug that solution back in, you're going to get a 0. Who says I understand that? Okay, that's a big part of today's lesson. Okay, so let's just come right here and let's look at example 2. Use the remainder theorem and the factor theorem, and then use the factor theorem to determine if that x plus 3 is really a factor. Okay, so everybody write down the word factor, and then I want you to write down the word 0. You could have written 0, you could have written root, you could have written solution. We already talked about that a couple of lessons ago. So the factor is x plus 3. That's like this. Let me show you just really fast. See how I solved that? And that's a factor, and that's a factor. So they want to know, is that a factor, is the question. Well, if x plus 3 is a factor, then x equals -3 would be the solution. Okay, so I'm going to take that -3 and I'm going to plug it back in. So everybody go -4, in parentheses, put a -3 to the third, plus 5 times a -3 to the second, plus 8. Now, I know that someone has told me I don't like to store, I don't store values in my computer or in my calculator. It really is like a computer because it's confusing. You have to overcome that if that's you, because we're going to store so many numbers in today, okay? So everybody grab your calculator, and I want you to hit the white negative button and then the 3 and then hit store enter. Now I want you to plug in this part, the first parenthesis of that problem. Okay, so hit the white negative button, 4, membar enter. And the way you raise something to the third, guys, on the left side about 5 button up is that caret button. So you hit that up, raise it to the third, plus 5, membar enter, x squared, plus 8, hit enter, and you get 161. So this is a yes or no question. Is x plus 3 a factor? And lots of you are shaking your head no. How do you know that the answer is no? Because you actually had a remainder. You had a 161 instead of a 0. So is x plus 3 a factor? No, it's not. Okay, let's do the next one. Okay, write down the word factor and put in x plus 2. Then put the word 0, and it would be x equals -2. You don't have to do that when you do this problem. I'm just trying to enforce to you what's a factor and what's a 0. Okay, bless you. So everybody go 3, -2 in parentheses to the third, plus 6 in parentheses, -2 squared, minus 15 times -2 times minus 30. Okay, let's all go -2, store, enter. Then let's put that in. So 3, membar, enter. Hit that caret button, that up arrow on the left to the third. Plus 6, membar, enter, x squared. Minus 15, membar, enter. Minus 30, enter. And we got a 0. Is x plus 2 a factor, guys? Yes, it is. What does that mean? Okay, let me show you what it means. Just look and listen. Lots of little just connections in you listening today. Look right here. If I were to factor that, I would have something and something and something because it's a cubed, 3 of them. Well, now I know for sure that when that is fully factored, one of those factors is x plus 2. Who says I understand you? Okay, it's because you guys are awesome. Okay, now we're going to talk about synthetic division. Those of you who know synthetic division, you're happy and you're like, yes, and you're smiling and you're glad because it's 5 times easier than long division. It is. I have had a couple of people say to me before, I don't really understand synthetic division. I'm going to stick with long division. Okay, don't do that. You want to overcome that. It's going to take you a lot of time to do long division, and synthetic is quick and easy. Okay, I'll go slowly though, just to give you some time to let it click. Okay, so this problem right here, example 3, is the exact same problem as example 2, if you notice that. Okay, so then look what I do. If you take that x plus 2 equal to 0 and set it equal to 0, you get x equals -2. That's the number that goes over there. So you take the second parenthesis, set it equal to 0, that's what goes there. Then look at these exponents, guys. 3, 2, 1, constant. I'm not missing anything. So now I take those coefficients, 3, 6, negative 15, negative 30, and that's how those got there, okay? Okay, see this 3 right here? Whatever that number is, it always just comes straight down. Then you take that number and you multiply it by negative 2. So 3 times negative 2 is a negative 6. Now I combine a 6 and a negative 6, and when I do, I get a 0. Now you just repeat. 0 times negative 2 is 0. A negative 15 and 0 is negative 15. A negative 15 times a negative 2 is a positive 30, and I have no remainder. Okay? If you have no remainder, then you know x plus 2 is a factor. Okay? So I'm going to write this down. Write down, put a little asterisk and say if there is no remainder. You know two things. You know x plus 2 is a factor, and you know x equals negative 2 is a solution or a root or a 0 or whatever they're choosing to call it at that moment. Okay? Okay, another thing I want to show you guys is this. People get confused on this. They get a little hung up on this, so I want you to watch. You see this exponent right here is a 3. And I did synthetic division one time. One process of division. 3 subtract 1 is a 2. So this guy right here is an x squared, x to the second power. So this is 3x to the second plus 0x minus 15. Which you guys know you don't need the 0x, so it's 3x to the second minus 15 is what you end up once you do synthetic division one time, okay? Who says I understand? Okay, great. Okay, example 4. Is this a factor? And then find all of the zeros, okay? So what we're going to do is you're going to set x plus 2 equal to 0, and you're going to get a negative 2. And then look at your exponents, guys. You have a 4. You're missing the 3. You've got a 2 and you've got a 1, and you're missing the constant. So you have to go 1, and then a 0, and then a negative 7, and a negative 6, and a 0. So I had a couple of zeros I had to fill in. And yes, I want you to have a 0 constant. Okay, I want you to have a constant. So if it's not there, fill in a 0. Okay, pull this 1 down. 1 times negative 2 is negative 2. A 0 and a negative 2 is a negative 2. A negative 2 times a negative 2 is a positive 4. A negative 7 and a positive 4 is a negative 3. A negative 3 times a negative 2 is a positive 6. A 6 and a negative 6 is a 0. 0 times negative 2 is a 0. And I have no remainder. Is it a factor, everybody? You guys tell me. Yes, it is. Okay, so let's write the word yes, because that's the first question. Then the rest of the problem says find all of the real zeros. Okay, now watch this. This is a 4. I did this once, so this guy's a what, everybody? A third, right? 4 minus 1 is a 3. So it's going to be x to the third minus 2x to the second minus 3x. Now I could write plus 0, but does that do me any good? Doesn't do me any good. And if I'm looking for zeros, I'm looking for the solutions, which means I need to set it equal to 0. Okay? You tell me, what would you do right there to solve this, guys? Take out an x is exactly right. And when you do, you're left with x to the second minus 2x minus 3 equals 0. And then that continues to factor. So it goes to x and x. The 3 goes to 3 and 1. Signs are different. Biggest is the negative. Looks like that. Set that equal to 0. I get x equals 0. Set that equal to 0. I get x equals negative 1. Set that equal to 0. X equals positive 3. And I'm done. It's wrong. You don't put it in ordered pairs. Why don't you put it in ordered pairs? What would they have said if they would have wanted it as an ordered pair? Intercepts, exactly right. Good, intercepts. There's still a chance you might get it, but you know, it's always debatable. We always get into these big discussions whether or not to give it to you. So there's something wrong with this though. This is an x to the 4th, which means I should have 4 solutions. I only have 3. So what's the problem? What's the problem, honey?
Like the -2.
Yeah, this is a solution as well, right? Okay, so on that answer line, also write in x equals -2, and then we're done, okay? Now, I want you to freeze right here. This is super important, okay? You're going to study for a lot of hours for your midterm. Like, all in all, I bet it's going to be close to 8. But we're going to break it down, and it'll be fine, so don't get stressed. But my point is you're going to study really hard. So then when you go to take the test, it's so empowering if you guys can check your answers, because you did all this studying, and then you can check your answer. I can check this answer in less than a minute. And I know without a doubt, I walk away and I'm like, I totally got that problem right. Like, there's no way I missed it. So how would I do that in this problem, everybody? Plug in all those numbers, and when I plug them in to that original, what should I get? A 0, okay? And you do. You get a 0 for every single one of them. We'll check one in a little bit, but we won't do that one. Okay, look at example 5. Show that these are factors of this, and find all of the remaining real factors, and leave your answer in factored form. Okay, everybody look right here, okay? This is big right here. This is the whole point of this lesson. Listen, if someone gave you this and asked you to solve it, well, you don't write any of this down. You would set it equal to 0, and then you would start factoring. Well, how the heck am I supposed to factor that? It's huge, right? How am I supposed to do that? Well, then what you guys did last year, when you had the graphing calculator, you would hit y equals, you would graph it, you would see where it hit the x-axis, and that's where you would start your division. Who says, I understand that and I remember that? Okay, but we don't have a graphing calculator. They won't let us use one. So what the heck are we supposed to do? Well, I'm going to show you in a minute how we begin, but this one's easy where we begin because they told us that they're factors. It says show that they're factors. That means that they're definitely factors, okay? So once again, just to make sure that everybody's good, I want you to write down the word factors, and then I want you to write down the word zeros. So if you have a factor of x minus 2, then you have a 0 of x equals 2. If you have a factor of x plus 3, then you have a 0 of x equals -3. Okay, so let's start with the 2. Put your 2 right here. We're going to do synthetic division, and we better not get a 0 because we know that that they're factors, so we know that's a solution. Look at your exponents. 4, 3, 2, 1, constant. I'm good. So everybody go 2, 7, -4, -27, -18. 2 comes down. 2 times 2 is 4. 7 plus 4 is 11. Times 2 is 22. 22 subtract 4 is 18. 18 times 2 is 36. Combine those and I get a 9. 9 times 2 is 18. I know I'm doing this right. Okay, so I did the 2. Now, just look and listen here for a second. Don't write anything. I could do this. Look, I could do 2, -7, -4, -27, -18, blah, 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 no remainder. But the point is, I'm trying to take that big, huge guy that I started with, and I'm trying to like make him smaller, make him smaller, make him smaller. So if I do them separately, I'm not really helping myself. So I'm not going to do a separate thing. I'm going to stack them on top of each other. So now I'm going to put a -3 right here, and I'm going to do the same thing. And I also, again, better not get a remainder. So the 2 comes down. 2 times -3 is a -6. 11 minus 6 is 5. 5 times negative 3 is negative 15. 18 minus 15 is 3. 3 times negative 3, negative 9, no remainder. Right? Okay, so this is a 4. I did synthetic division twice. 4 minus 2 is a 2. So now I have 2x to the second plus 5x plus 3. What do they want me to find? They want me to find the remaining factors, not solutions. So I'm not going to set it equal to 0. I'm just going to keep factoring. So it's going to go to a 2x and a plain x. Signs are the same. They're both positive. And I feel like I didn't do anything wrong. I'm good. It's going to be 3 and 1 like that, because that gives me 2x and 3x, and that adds to give me 5x, and that's it. So those are the remaining factors, and that's what they asked me for. Okay? Just a very quick addition to this. If they asked you for the full factorization, then it would be f of x equals, it would be the x minus 2 and the x plus 3, which is what I started with, and then it would be 2x plus 3 and then x plus 1 along with it. Okay? If they asked you for all of the zeros, you would have x equals 2, negative 3, negative 3 over 2, and negative 1. So there's lots of different things they could ask you. Remaining factors, full factorization, or all the solutions. Okay? All right. Here's what it's really going to look like right here. Okay? Not number 6. 6 is too easy. But this is the idea of what this is really going to be like. Okay, so if someone asked you to solve that, could you factor that? Okay, well, I look at that and I actually don't think I could. So no is the answer. So how in the heck do I start doing this if I don't have a graphing calculator and I have no idea how to factor that? Here's what you do, okay? Write down the word constant. The constant is the number that's in that equation that has no variable with it, so that would be a 3. And then I want you to write down the words leading coefficient. So do you see the biggest exponent is a 3? Do you see the coefficient in front of that, or the number in front of that? That's a 2. So in this problem, the constant is 3 and the leading coefficient is a 2. Now what you have to do is you have to list the factors of each of those. Factors are numbers that go into those. So do you see how the constant's a 3? What goes into 3? 1 and 3. Do you see how the leading coefficient is a 2? The factors of 2 are 1 and 2. Okay, so here's what you do. You take the factors of the constant and those go on top. You take the factors of the leading coefficient and those go on bottom. Now, that's not how you write it. The top is either a 1 or it's a 3. The bottom is either a 1 or a 2. So you just have to pair those all up, okay? So it could be 1 over 1, 1. Now change the bottom to a 2. That would be 1 over 2. Now I've done them all with the top as 1, so now I'm going to make the top be a 3, okay? So 3 over 1 is 3. 3 over 2 is 3 over 2, okay? Go get a drink, sweetheart. Go get a drink. Are you okay?
Yeah.
Are you sick or are you tired?
I was last week. I just kind of sleep last night. I'm really tired.
Are you okay? Go get a drink, okay? Maybe think about taking off your jacket. Oh, you don't have a jacket. Okay, well, don't take that off. Okay. You got to get a little uncomfortable, okay? You're too comfortable right now. Okay, so here's what we have, right? It's the plus or the minus of all of those numbers, okay? So those are the possibles. Now, this is a true story. First time I taught 1050, long time ago. This is how I had my students write it. Everybody missed the problem because Weber State didn't like how this was written. What do you think is wrong with this? If you write it like this, you will lose all the points for sure. Liam, what do you think, bud?
It looks like it's just a plus and minus 1.
Exactly. So how can we fix it, buddy?
Either like parentheses or writing plus and minus within each of them.
You're exactly right. And I just throw parentheses. So we've got 4. Okay. Now, these are not for sure solutions. They might be solutions. Okay. So now we're going to find one that is a solution. Grab your calculator. How am I going to find one that's a solution? Like, how will I know when it's a solution? Plug it in, get a 0, right? Everybody go 1, store, enter. Then go 2, membar, enter, raise it to the third. Plus 3, membar, enter, x squared. Minus 8, membar, enter, plus 3, enter, and I found one already. Okay, so everybody write down x equals 1. I know that that is a rational 0. Now I'm going to do synthetic with a 1. On the other numbers are 2, 3, -8, and 3. Then I draw a line right there. The 2 comes straight down. 1 times 2 is 2. 3 plus 2 is 5. 5 times 1 is 5. A -8 and a +5 is a -3. Times 1 is a -3. No remainder. I know I'm doing it right. Okay, so the third went down to a second. So this is now 2x to the second plus 5x minus 3. And since I'm looking for zeros or solutions, I'm going to set it equal to 0. Let's see if it factors. So the 2x to the second is going to go to a 2x and a plain x. The 3 is going to go to a 3 and a 1 like that, because that gives me 6 and 1, which subtracts to give me 5. So that's it. The biggest is the positive, so the positive goes here, and the negative goes there. Set that equal to 0, you get x equals 1/2. Set that equal to 0, you get x equals -3. You have to include the x equals 1 that we started with as well. Those are my answers. It's an x to the third. I'm only supposed to have 3 answers. I'm done. Like, that problem's over. The other zeros, there are none. Other zeros, none. What is an other zero? Like, what is that? If something ends up with a square root in your answer or an I, it's considered an other zero. Now, several years ago, Weber State used to make me separate the rationals from the others. I don't think they're going to do it. I think they're just going to say, find all of the zeros, and you guys just do your thing and list them in it. I think it's going to be easier than this. But we'll do this just in case, okay? Okay, here we go with 7. Constant is a 4. What goes into 4? 1 and 2 and 4. Leading coefficient is the number in front of the x to the third. That would be a 2. What goes into 2? 1 and 2. So your options are 1/1, which is a 1. 1/2, which is 1/2. Now change the top to a 2. So it'd be 2/1, that's a 2. And then 2/2, that's a 1, but I already listed it, so I don't have to do it again. Now I do the 4. 4/1 is a 4. And then 4/2, that's a 2. So I'm good. It's the plus or minus of all of those. And then I put parentheses around them. And those are my possibles. Last period, someone was like, you've got a 2, but a 2 is not a solution. It doesn't have to be. Those are the things that might be solutions. So it's just a starting point. Okay, everybody grab your calculator. Everybody go 1, store, enter. Put in the original, 2, membar, enter, raise it to the third, plus membar, enter, x squared, minus 9, membar, enter, plus 4, enter, doesn't work. Why do I say doesn't work? Because I didn't get a 0. Good, thank you. -1, store, enter, up, enter, doesn't work. See the 1/2? I'm skipping over that because it's a fraction. So let's go to the 2. 2 store, enter, up, enter, doesn't work. -2 store, enter, up, enter, doesn't work. 4 store, enter, up, enter, doesn't work. -4 store, enter, up, enter, doesn't work. So now I'm left with the fraction. Okay, so I'm going to go 0.5, store, enter, up, enter, and it works. Okay, so everybody write down x equals 1/2. And people are really bad at writing on part B to here's my rational. So why don't you write it right now and highlight it? That way we know we're like not going to miss it. We've written our to. Okay, let's do the 1/2. Look at the exponents. 3, 2, 1, constant, not missing anything. 2, 1, -9, 4, draw the line. Freeze for just a second. When I'm done with this synthetic division, if I'm doing it correctly, what's going to happen? Everybody tell me. No remainder. Okay? 2 comes down. You have a couple of options. You could go 2 times 0.5 equals every time. I'm not going to do that because multiplying by 1/2 is the same thing as doing what, everybody? Dividing by 2. 2 divided by 2, 1. 1 plus 1 is 2. 2 divided by 2, 1. -9 and a positive 1, -8. -8 divided by 2, -4, no remainder. I think it's awesome you're not supposed to have a remainder because it's like this sweet little check right in the middle of my problem. Am I doing this right? Of course I'm doing it right. I didn't get a remainder, right? Okay, everybody write down 2x to the second because it's a 3, did synthetic 1, so it takes it to a squared. 2x to the second plus 2x minus 8. I'm trying to solve for a 0, so I'm going to set it equal to 0. You tell me what to do. What would you do? Take out a 2. Then you're left with x to the second plus x minus 4 equals 0. Does that factor? It does not factor. If it doesn't factor, now we're down to others. Okay, so come down to the other zeros and write x to the second plus x minus 4 equals 0, and let's solve that. Could I complete the square? Yes. Would I? No. I'm going to use quadratic. So I'm going to go x equals -1 plus or minus the square root of 1 squared is 1 minus 4 times a, which is 1, times c, which is a -4, all over 2 times 1, which is a 2. Freeze for 2 seconds. Your midterm's going to be here before you know it. Do I have permission to write this as a decimal? No. If I had permission, what would it say? Round to the blah, 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 blah. There was an exception, remember the other day, and that was, you remember? Money. Remember, money, we're like automatically going to put that 2 digits. Okay, grab your calculator, and this is what I want you to do right there. See that yellow? That's what you're going to put in. When you put that in, you get 17. Writing your answer like that is completely acceptable. This is a third power, and I have 1 answer there and 2 more answers there. I'm good. Everything's done. If this is on your midterm, please check it. We're going to check it right now. See that stuff right there? We're going to put it in our calculator. We're going to do the whole thing together. Okay, here we go. Everybody go. What's the very first button you have to push? Parenthesis. Good. White negative button, 1. Plus second x squared. 17. Look at your calculator screen. How many closes do we need right there? Tell me. 2. You guys are so awesome. 1 for the radical, 1 for the top. Then hit divide 2, store, enter. Now it's already in my calculator because I did it up there for the possibles, right? So just hit up, up. Now you're on top of it again. Hit enter. Got a 0. Okay, let's check the other one. Up, up, right, right, right. Make the positive a negative. Hit enter. I just stored it. Then I go up, up, enter, got another 0. I just checked it. And if I wouldn't have spoken while I did that, I bet it would take me 35 seconds to check it. Yes, honey?
Are there times when only the positive or only the negative is 0?
No, no. But that's a good, I mean, if you're stressed for time, and if you're like, I want to check them, but I'm afraid to take too much time, check one and it's going to be good. Good question. Okay, this one's kind of tough. This one's a little tough. Just some funny stuff. So just be careful with this one, okay? Who says, I understand so far and I feel good about this lesson? Okay, so good news. You feel good about this. Next time's almost like you're going to go through it and you're going to be like, that was the same lesson. Like it was the same. And that's all that's on your midterm. Like we're done after that. We have to keep learning because we got to get ready for the final. But that's all that's on the midterm. So that's good. Okay, here we go with possibles. Constant is a 16. What goes into 16? 1, 2, 4, 8, and 16. Yes. We're going to do that. We're going to stick a plus or minus in front of it. Yes. So you are correct. Do not include the negative with it. Yes. Leading coefficient is a 1. The only thing that goes into 1 is 1. Is that necessary? Say it again. Biggest exponent's a 5. The number in front is a 1. Yep, you're good. So is dividing by 1 writing that thing necessary? No. So just get rid of it. And then I'm going to put parentheses around it. I'm going to put a plus or minus in front of it. And that's it. You guys, I'm telling you, like I would bet money right now that this will be on your midterm. And if you don't have the parentheses, they're going to take off every point. I know it. Okay? Okay, let's start plugging in. Everybody go 1, store, enter. Remember this example is a little tough. Membar, enter, raise it to the 5th. Minus 5, membar, enter, raise it to the 4th. Plus 12, membar, enter, raise it to the 3rd. Minus 24, membar, enter, x squared. Plus 32, membar, enter, minus 16, enter, and it worked. Come right here and write x equals 1. And if I were you, I'd highlight it right now. So then I don't forget to write it, because a lot of people forget. Okay, put your 1. Look at your exponents. 5, 4, 3, 2, 1, constant. I'm good. So your numbers are 1, negative 5, 12, negative 24, 32, negative 16. Draw the line underneath. 1 comes down. 1 times 1 is 1. What better happened right here? Tell me. By the time I'm done with this, no remainder. Good. Negative 4. Negative 4 times 1, negative 4. Positive 12 and negative 4, 8. 8 times 1 is 8. Negative 24 and a positive 8 is negative 16. Times 1, negative 16. Combine those, 16 times 1, 16. Beautiful. Okay? Now freeze and let me say something. Don't write this down. This is a 5th. This is a 4th. X to the 4th minus 4x to the 3rd plus 8x to the 2nd minus 16x plus 16. Do I know how to factor that? I don't. So I haven't broken it down enough for it to be something I can deal with. So I'm not done. I'm not done with this synthetic business. What should I do? Say it again. Keep testing more numbers. You know what someone said last period? Do the 1 again. We don't know the 1 is the solution twice. You know what I mean? If we knew that it bounced, we could do it again. But I don't know, so there's no way I would do that. Okay, let's do negative 1. Negative 1, store, enter, up, up, enter, doesn't work. 2, store, enter, up, enter, and it works. So right there beside x equals 1, I'm going to write x equals 2. They're both rational. Put a 2 right here. Synthetic again. 1 comes down. 1 times 2 is 2. A negative 4 and a positive 2 is a negative 2. Times 2 is a negative 4. 8 minus 4 is 4. 4 times 2 is 8. 8 and a negative 16 is a negative 8. Negative 8 times 2 is a negative 16. No remainder. Okay? Don't write this down for just a second. But here's what I have. I did synthetic division twice. I started with a 5. 5 minus 2 is a 3. So I have an x to the third minus 2x to the second plus 4x, excuse me, minus 8. I don't know if it factors. I can look at it and I know it factors by looking at it. So I want to train you to be able to see the same thing I can do. This is difficult to understand, so I want you to watch. Look at the bottom of that synthetic. Pair these up together. Pair these up together. See the little ones? Leave them alone. See the bigger ones? Can I take something out of 4, take the same thing out of a negative 8, and turn them into 1 and negative 2? Yes, I can take out a 4. 4 times 1 is 4. 4 times negative 2 is a negative 8. That little trick tells you it factors. So I look at it, or I look at that, and I go 1, 2. Can I turn that into a 1, 2? Yeah, I can tell it's going to work out. Okay, so let me do it. Set it equal to 0, and let's factor. Did I see somebody's hand up?
I did, but never mind.
You're good? Okay, no problem. See the x to the second, or x to the third, pardon me? Split that to an x to the second and an x to the first. It does not matter which one's listed first. Okay? I know you've done this before. It's very simple. You need a negative 2x squared. Whatever goes right there is going to be multiplied by the x squared. So what do I have to put there to make it a negative 2x squared? Negative 2. I need a positive 4x. Whatever goes here is going to be multiplied by the x. What is needed? A plus 4. Now the only other thing I always do just to make sure that that really is the correct factorization is I just say in my head, is a positive 4 times a negative 2 a negative 8? Yeah, so it factored correctly. Okay, now the x minus 2 gives you x equals 2, and I've got that here. Okay, I've got that right there. This x squared plus 4 doesn't factor. So I'm going to take it to my other 0. So x to the second plus 4 equals 0, and now I solve that. I could use the quadratic formula. I would never use the quadratic formula. I can just square root. So if I move my 4 over, I get x squared equals negative 4. Then I square root it, and I get x equals, tell me what comes right after the equals, plus or minus, and what's the square root of a negative 4? 2i. Okay, done. Freeze right there. Now I'm confused. I just don't want you to get freaked out if this happens. This is a fifth, which means I'm supposed to have 5 answers, right? And I have 1, 2, 3, 4. Where's my other answer? Where did it go? Where did my other answer go? Say it again.
Does that have anything to do with the x squared?
No, because the squared gave me 2.
Oh, that's what
Is it from the
right?
first set of green highlighted numbers?
No. And other people were saying that too because they're like, well, maybe there's another one in there. Listen to this comment. People were saying maybe there's another one in there. If there was another one in there, it would have revealed itself during this process. So there's not like this imaginative one that didn't show up. Tell us, bud.
Are there 2 2s?
Talk to us. You're exactly right. Talk to us about that. Show us, like describe where it is and walk us through it.
You used the first two in the synthetic division, and then you got the other two in the answer over there.
Do you see that? I just kind of glossed over it. I said, well, this you got the 2. That was clear. And then I said, this gives you a 2, but I've already got it listed, so we're good. That was the wording I used. So if we graph this, which we are not going to graph this, but if we did, when it came upon that 2, what would it do? It would bounce because it's a solution twice. So we really have 5. We have 1, 2, 3, 4, 5. Who says I understand? Okay, the lesson's pretty much over. This little example right here, it did pop up. This thing popped up like, I don't know, 2.5 years ago. I don't think you're going to see it, and it's easy anyway. Who cares? Okay, so draw your XY axis. Come out here to a positive 3. If I put in a positive 2 and I got a negative y, and if I put in a positive 3 and I got a positive y, and in order to graph the function, I have to connect those points. It has to cross through the x-axis. Therefore, there has to be a solution between them. Okay, who says I understand that? Okay, so let's just plug those in and see if our y values are different, right? So you're just going to do a table. You're going to use x equals 2 and x equals 3. Grab your calculator and go to store enter. Membar enter, raise it to the 3rd. Minus 2, membar enter, minus 5, enter, and I get negative 1. Now do the 3. 3 store enter, up, enter, and I get 16. So they're different signs, so obviously it has to cross in the middle, right? Okay, let's write it up. So let's say f of 2 equals negative 1. And f of 3 is equal to 16. The y values have different what, everybody? Signs. Yeah. Comma. So there must be a real 0 between them. I think you have about a 0% chance of that being on there. But just in case, we got to be ready. Okay, that is it. Is quiz 2 going to be easy? Tell me that. No. Is it going to demolish your grade? Tell me that.